Automotive engine. The engine provides the power to drive the vehicle's wheels. All automobile engines, both gasoline and diesel, are classified as internal combustion engines because the combustion, or burning that creates energy, takes place inside the engine. The biggest part of the engine is the cylinder block. The cylinder block is a large casting of metal that is drilled with holes to allow for the passage of lubricants and coolant through the block and provide spaces for movement of mechanical parts. The block contains the cylinders, which are round passageways fitted with pistons. The block houses or holds the major mechanical parts of the engine. The cylinder head fits on top of the cylinder block to close off and seal the top of the cylinder. The combustion chamber is an area into which the air-fuel mixture is compressed and burned. The cylinder head contains all, or most of the combustion chamber. The cylinder head also contains ports through which the air-fuel mixture enters and burned gases exit the cylinder. The valve train is a series of parts used to open and close the intake and exhaust ports. A valve is a movable part that opens and closes the ports. A camshaft controls the movement of the valves. Springs are used to help close the valves. The up and down motion of the pistons must be converted to rotary motion before it can drive the wheels of a vehicle. This conversion is achieved by linking the piston to a crankshaft with a connecting rod. The upper end of the connecting rod moves with the piston. The lower end of the connecting rod is attached to the crankshaft and moves in a circle. The end of the crankshaft is connected to the flywheel. Engine construction. Engine classifications. Today's automotive engines can be classified in several ways, depending on the following design features. Operational cycle. Most users will generally come in contact with only 4-stroke engines. However, a few older cars have used, and some cars in the future will use a 2-stroke engine. Number of cylinders. Current engine designs include 4, 5, 6, 8, 10, and 12-cylinder engines. Cylinder arrangement. An engine can be flat, or opposed, inline, or V-type. Other more complicated designs have also been used. Valve train type. Engine valve trains can be either the overhead camshaft type, or the camshaft in overhead valve type. Some engines separate camshafts for the intake and exhaust valves. These are based on the overhead camshaft design, and are called dual overhead camshaft engines. V-type double overhead camshaft engines have 4 camshafts, 2 on each side. Ignition type. There are 2 types of ignition systems, spark and compression. Gasoline engines use a spark ignition system. In a spark ignition system, the air-fuel mixture is ignited by an electrical spark. Diesel engines, or compression ignition engines, have no spark plugs. An automotive diesel engine relies on the heat generated as air is compressed to ignite the air-fuel mixture for the power stroke. Cooling systems. There are both air-cooled and liquid-cooled engines in use. However, nearly all of today's engines have liquid cooling systems. Fuel type. Several types of fuel currently used in automobile engines include gasoline, natural gas, diesel, and propane. The most commonly used is gasoline. 4-stroke gasoline engine. In a passenger car or truck, the engine provides the rotating power to drive the wheels through the transmission and driving axles. The operation of a 4-stroke power engine has 4 different stroke, takes place in every 2 engine revolutions to produce 1 power output to drive the car. Intake stroke. The first stroke of the cycle is the intake stroke. As the piston moves away from top dead center, or TDC, the intake valve opens. The downward movement of the piston increases the volume of the cylinder above it. This reduces the pressure in the cylinder. This reduced pressure, commonly referred to as engine vacuum, causes the atmospheric pressure to push a mixture of air and fuel through the open intake valve. As the piston reaches the bottom of its stroke, the reduction in pressure stops. This causes the intake of air-fuel mixture to slow down. It does not stop because of the weight and movement of the air-fuel mixture. It continues to enter the cylinder until the intake valve closes. The intake valve closes after the piston has reached bottom dead center, or BDC. This delayed the closing of the valve increases the volumetric efficiency of the cylinder by packing as much as air and fuel into it as possible. Compression stroke. The compression stroke begins as the piston starts to move from BDC. The intake valve closes, trapping the air-fuel mixture in the cylinder. The upward movement of the piston compresses the air-fuel mixture, thus heating it up. At TDC, the piston and cylinder walls form a combustion chamber in which the fuel will be burned. The volume of the cylinder with the piston at BDC, compared to the volume of the cylinder with the piston at TDC, determines the compression ratio of the engine. Power stroke. The power stroke begins as the compressed fuel mixture is ignited. With the valves still closed, an electrical spark across the electrodes of a spark plug ignites the air-fuel mixture. The burning fuel rapidly expands, creating a very high pressure against the top of the piston. This drives the piston down toward BDC. The downward movement of the piston is transmitted through the connecting rod to the crankshaft. Exhaust stroke. The exhaust valve opens just before the piston reaches BDC on the power stroke. Pressure within the cylinder causes the exhaust gas to rush past the open valve and into the exhaust system. Movement of the piston from BDC pushes most of the remaining exhaust gas from the cylinder. As the piston nears TDC, the exhaust valve begins to close as the intake valve starts to open. The exhaust stroke completes the four-stroke cycle. The opening of the intake valve begins the cycle again. This cycle occurs in each cylinder and is repeated over and over as long as the engine is running.